Hello, welcome. I got a question in lesson 4, unit 2 for calculus, number 9. So it says find vector, parametric, and symmetric equations for the following. So here we have standard form. So from this equation, we know that our normal is equal to negative 4, 6. And we're just going to reduce that down. Both are divisible by 2, so negative 2, 3 is my normal. For any of these other forms, to get vector, parametric, and symmetric, we need to know a direction vector. So again, remember that for any line, standard notation, we have the normal. So for this one, if this represents the line, my normal is right here. So this is the line. So we want a direction vector, which is in the direction of the line. Those two are perpendicular to each other, which means that we can find our direction vector by doing the normal dot direction vector has to equal 0. So negative 2, 3 dot xy equals 0. So if we just take that information and figure it out, or use that setup, we get negative 2x plus 3y equals 0. So if we can find some combination, so therefore I'm just going to let x be 3 and y be 2. So therefore my direction vector is 3, 2. Now I can use that information to find my various forms. So going into vector notation, I still got to find a point on the line actually. Sorry, almost have all the information needed. So I need direction vector, but I need a point as well. So to find a point, I'm going back to the original equation. So this is the equation of the line. I'm just going to say let x equals 0. Makes my life semi-easy. So negative 4 times 0 plus 6y plus 9 equals 0. So 6y equals negative 9. Y equals negative 3 halves. So therefore my point P is located at 0, negative 3 halves. And you can use any combination as long as you can get that equation equals 0. I know I don't have to do any math or any manipulations with that point, so I don't really care if there's fractions or not. I don't have to worry about doing any manipulations with it. So now to answer the question, we would have the point, or our reference point on the line, plus t times the direction vector. Moving to parametric, we would have x equals, I'll put the 0 in for emphasis, but it would just be 3t. Y equals negative 3 halves plus 2t. And then from that, we can move to our symmetric form, where it would be x over 3 equals y plus 3 halves over 2. So there are our three forms, our vector, our parametric, and our symmetric. All right, that is how you do this particular question. It's going to be important in this process moving forward because you'll have to do this in 3 space, but it's the same process. Step 1, find your direction vector using the normal. Step 2, find a point. Once you have a direction vector and a point, you are all set to set it up into the 3 equations. If you have any specific questions about this, let me know, and I will do what I can to answer them.